Hi Year 4, good afternoon and welcome to Thursday the 14th of January's science lesson. Again, we're continuing with forces and magnets, and we will begin our lesson today with, yes, you guessed it, a quick retrieval quiz. So make sure you've got your pencil or pen and paper at the ready. Here we go. Okay, quick quiz time. Number 1, name the two poles of a magnet. I know you know this one. Come on, we can do that. Number 2, when the north pole of a magnet and the north pole of another magnet meet, and I'm looking for one word here, it's based on what we were looking at yesterday when I was putting those magnets together. So when a north pole and a north pole meet, they do what? Number 3, when the north pole of a magnet and the south pole of another magnet meet, they do what? So again, one word I'm looking for that one there. Okay, fantastic. Number 4, a is the invisible pulling force around a magnet. Now you should remember this one from yesterday. It was in our quick quiz in yesterday's lesson, and I had to quickly change the sound word in my PowerPoint yesterday because I've written it down incorrectly. So hopefully that might aid your memory, my little mistake there. So is the invisible pulling force around a magnet. Number 5, the Earth acts like a giant what? What does it act like? And finally, number 6, a compass always points what? 2 words with a hyphen in between them for this answer here. Okay, pause if you need to catch up or to go back on all of those questions. Otherwise, keep playing and then we'll go through the answers. Right then, here we go. A different colour to mark in would be really good. Number 1, of course, the two poles of magnet are north and south. For question number 2, when you have the same poles together, when they meet, they will repel. Okay, they will repel. That means they will push away from each other. Number 3, when the north pole of a magnet and the south pole of another magnet meet, they attract. Okay, just like my 2 magnets here, north and south poles attract and they stick together. There's a pulling force pulled into the magnetic field. Talking of a magnetic field, that is the answer for question number 4, which of course is the invisible pulling force around the magnet. So even though we can't see it, around this magnet here is an invisible magnetic field, a pulling force. Number 5, the Earth acts like a giant magnet. Well done if you got that one. That was in our video yesterday, wasn't it? And finally, number 6, we've had this question before, so hopefully you've remembered it. A compass always points north, south. Okay, with the red hand of the compass pointing to north. Okay, usually when we hold it up like that. So let's take a little look then at some more marvelous magnets. Okay, and actually I'm really excited for today's lesson because in this lesson, by the end of it, you will have designed your very own magnetic game. Okay, so you can get really creative with this one and perhaps link it to our topic to do with the ancient Egyptians. You could link it to our story in our guided reading and reading for pleasure podkin. You could link it to any of our other learning that we've done. You could link it to our map working that we've been doing. So lots and lots of creative possibilities this afternoon. So let's get started. So our learning objective then is to explain how magnets attract magnetic materials. So we're looking at an explanation. And we have our 3 steps to success. Firstly, I can understand that magnetic pulling force can go through some materials. Who knew? The pulling force can go through some materials, and we'll have a little demonstration and look at that with my board here in a moment. And number 2, I can design a game that uses magnetic force. And step number 3, I can use scientific vocabulary to explain how the game works. Okay, let's just have a quick recap then on that idea for step number 1, that the magnetic pulling force of a magnet can actually go through some materials. Okay, so let's read this through together and then take a look at some examples in real life, and I'll also demonstrate as well. So let's see. Magnets have a magnetic field around them that produces a pulling force on some materials. This pulling force can go through other materials such as paper or wood. Let's try it. Let's place a magnet behind a piece of paper and see if a paperclip is attracted to the magnet through the paper. Okay, let's go into demonstration mode. Here we go. Let's try it. I'm just going to grab a piece of paper. Okay, like this. And I am going to get my paperclip, wondered where it was there for a minute. Like this, just going to hold it there for a minute. And the other side of my paper, I'm going to place a magnet. And let's see, oh, hello. There we go. Even through the paper, we can see that the magnetic field around the magnet is strong enough to pull in that paperclip, even though the paper is in between. And look what I can do here. If I hold my paper at the bottom, I can move like magic. Hey, maybe this is how some magic tricks are done. Even through the paper, I can move like magic. This paperclip, not magic, just science. Idea of a magnetic field. Fantastic. Now, of course, if there are some materials that are perhaps a bit thicker, maybe that magnetic field won't be strong enough. I'm just going to give this a go. Here I've just got a little coaster. It's kind of made out of card. I'm just going to see if this magnet has a strong enough magnetic field to attract my paperclip. It does, even though it's even thicker. And again, look, I can move my paperclip around using my magnet. Fantastic. I kind of want to see if it will go through something even thicker. Let's see. If you have magnets at home, by the way, I know not all of you will, and that's okay, just enjoy the demo. But if you do, then why not see if you can grab a paperclip or a coin or something that is magnetic that we know from the previous sessions, and grab a magnet and then just see if you can give this a try. You might want to pause the video now to give it a go and then catch up in a second. Now I'm going to give this a go. I'm not sure if it's going to manage to pull through this coaster. Okay, so I'm going to just see. This coaster is made sort of out of some plastic and some foam. So I'm not sure. Let's see. What do you think? Do you think it's going to pull it through? Do you think it's going to attract even through the foam and the plastic, or do you think that's going to be a bit too thick and the force, the magnetic field won't be strong enough? Let's just see. Oh my goodness. Even through the coaster, that paperclip is attracted into that magnetic field. Now I could carry on with this all day and get things that are progressively thicker and thicker and thicker until eventually it will get basically too thick and the magnetic field around the magnet won't be strong enough to pull through. I'm just going to give this a demonstration now on the desk here. So if I just move this down here, let's go to my desk, move my little things out the way. Okay, so I'm going to place my magnet on the table here so you can see. All right, and I'm going to, sorry, put my paperclip there. I'm going to take my magnet. Here we go. And I'm going to place it underneath this wooden desk. Now I'm moving, if you can hear, I'm moving this around the magnet underneath, but look, the wood is too thick and it cannot attract the paperclip into the magnetic field. Okay, so that's one magnet. I wonder if a slightly stronger magnet might work. Do you remember this from last time as well? My super duper telescopic magnet that can reach all sorts of things. I'm just going to try this and see if this works underneath. Placing it under. Oh, look at this. I have now found a strong enough magnet to move my paperclip. It's struggling a little bit, but if I'm really slow and careful with it, I can move my paperclip around because the magnetic field in this magnet is stronger. There's a bigger magnetic field, and I can therefore, even through solid wood, I can move this paperclip around. That is fantastic. What a joy. Okay, let's come back together, back to our slides, and have a look at some more examples of how magnetism, that's the magnetic force, can be used to help us in everyday life and in everyday items that we'll know. So let's go back to the slides then and see, shall we? So we have got a compass. Now, we've talked about this before, haven't we? A compass where we point north south. Okay, and we have that magnetic force from the earth, because the earth is like a giant magnet. It always attracts those points there to show you where north is. So the red, as I said earlier, is always the north point. Okay, and the white is the south point. So when your compass is here, even though it's labeled north here, you can move your compass around and the end for north would move around as well. And we know that north is always north, it stays the same, it doesn't move. So you'll know that actually the red pin is for north. So north would be in this direction over here. A fridge uses magnets. We talked about that last time, didn't we? To pull and hold the fridge door closed so the cold stays in and the food stays fresh. Vending machines, actually with coins, they will use magnetism with coins. I'll talk about that in a moment. And also laptops with the laptop screen. Let's investigate a bit further. Let's have a look. So these are useful magnets then. This magnetic force can be used, as we could see there, to point north in a compass. Okay, and that will always point north. To hold a fridge door closed, as we said. And this is the bit with the vending machine. It can sort the coins out between magnetic and non-magnetic coins. So remember we did this last week. We looked at my copper coin stuck to the magnet, didn't it? But my 5 pence didn't. Okay, so it can be used to sort out coins. They can be collected up and then exchanged for others. So you might have 100 pennies in your vending machine. They've been sorted out by magnets, and you can then collect those from the vending machine and exchange them for £1. Let's have a look here. A laptop lid. Now, I didn't know this at all until I had a look at this lesson. Actually, in a laptop lid, there are magnets so that the computer will know when the lid is closed and then it can shut itself down. So I had no idea about this. This is amazing. So actually in this very laptop that I'm talking to you through now, there are magnets. So if I were to shut my screen now, don't worry, I won't. But if I were to shut my screen now, my computer would shut down because the magnets, okay, would tell the laptop that the lid was closed. I'm not needed anymore. I can shut down, I can close. Fantastic. There we go. Who knew magnets were everywhere? Let's have a look then at some magnetic games. This is a really exciting bit. Let's use this knowledge that we know about magnetic fields going through materials, and let's see now if we can design some games that use magnetic force to attract materials. Now, there are several ideas for games that you may choose to design. We're going to take a look at some suggestions now, and then what I would do is I would think about all of the different suggestions and perhaps pick one, do a rough little sketch or a rough little drawing, test it out, and then when you're ready and you've decided on one, draw it out really neatly and then enjoy playing it. What would be brilliant by the end of this, by the way, is if you take a photograph of your work. That would be super duper, but why not take a little video of yourself playing the game and showing that magnetic force, that magnetic field, actually in practice, and we can have a go. So there are 3 types of games that we're going to look at today. We're going to look at a racing game, a fishing game, and a magnetic maze. Now, you may have some of these at home. So again, you might want to go and pause the video and see if you've got a magnetic game that you could grab to have a look and see how it works. So with a racing game, here's the suggestion. It says, how about creating a racing game? Draw a race track on card or paper, cut out cardboard people or cars to race on the track, and attach a paperclip to each one. By holding a magnet under the track, you can control a racer and move it around the track. Now, I've come up with a slightly simpler version of this game that I'm going to demonstrate for you now. Okay, so I'm just going to stop my share here for a moment. We're back in the demonstration mode. And you can see that I've drawn out some trees here. You might be thinking, Mrs. Fowler, why have you drawn out some trees there? Well, all shall be revealed. I was thinking about how the magnetic field, the force of a magnetic field can pull through some materials. And I wanted to test it out with my board here. Now, we've been introduced to my little easel here this week with our writing and our science yesterday. And I wanted to see if my paperclip would actually move across my board, whether if I can use my very strongest magnet that I have, and if I place it behind, whether I can actually move my paperclip here. And I thought about, well, what kind of game could I include for this? And I thought about the things that we've been learning about in our home learning so far this week, and instantly, especially considering the reading that we have been doing with Podkin, One Ear, I suddenly thought, well, actually, let's draw out, rather than a racetrack, let's draw out a forest. So you can see here I've got my very quickly drawn forest. And what I'm going to do, you can do this on a piece of paper or card. And if you do have a paperclip and a magnet, then even better, give it a go. But even if you don't, it doesn't matter. You can design the game and you can draw it out, and you can draw your paperclip, you can draw the magnet, you can draw out the playing area, whether it's a forest or a desert. Maybe it's going to be in the desert. Maybe it could be the archaeologist working his way through different artifacts. Go crazy, go wild, be really imaginative, think of lots of different ideas and then pick your favorite. And then you can, at the end of the lesson, explain how it would work if you could use the actual materials themselves. So let us see, without further ado, shall we see if my forest maze will work? You need to use your imagination here. This paperclip is no longer a paperclip. Oh no, this paperclip is Podkin, okay? This is the forest, okay, that he is running through to escape the Gorm, okay? And I'm going to see if I can attract this paperclip. Aha, no hands here. I've got my magnet behind my board, and what you can see me doing is I can move Podkin, quick, gotta escape the Gorm. I can move Podkin through my forest, out to the other side, and hopefully to safety from the Gorm. Okay, so that's how it would work there. So you could have your game area here, could be a forest, could be a desert, could be an archaeological site with different artifacts. It could be, I don't know, maybe we could do like a hurdles. You could get your paperclip to do the hurdles. It could be a running track. It could be like a cars track, like a sort of a racing circuit. You could draw it. Oh yeah, let's have a go, shall we? Oh, this is exciting. You could, like Le Mans or the Nürburgring or something like that, like a famous racetrack. You can kind of draw it out. Let's see if we can include some loops in here and some chicanes, I think they call it. So imagine it was a big loop. You could make yours a bit more adventurous, couldn't you? But let's say, oh, this is a strange old track, very loopy. Okay, so we've got our road here, and you could try imagining that this is a racing car. Okay, you could try to guide, see if I can find it. Where's my magnet going? There we go. You could see if you can follow the racetrack course round all the bends. Woo, here we go. Round. Oh, that's a tight corner. Oh, race car navigated that one well. All the way round. Back to the start. There we go. Isn't that so cool? And you could also add in little details, like you might have your start line here. You can draw yours out a lot more neatly than that. You have your start and finish there. Okay. You might want to use more than one paperclip, or use the idea of more than one paperclip, so you could actually race the two cars around the track. That could be great fun. But that's sort of the idea, sort of a simple idea of using magnetism to race around somewhere or to get through some sort of maze. Right, back to the screen then. And then we're going to have a look at a second idea. Right, okay, now I'm sure many of you have played this game when you were younger. You may even still have it. Okay, but we're going to take a look at this kind of game. It is a fishing game. Okay, so it says here, or you could create a fishing game. Draw a pond on cardboard or use a bowl or a tray. It says cut some fish shapes out of cardboard and attach a paper clip to each one. Place them in your pond. Tie a magnet to a straw or dowel with a length of string to make a fishing rod. Use the fishing rod to catch fish from the pond. Right, shall we take a little look at this one then? Let's go back together. And for this one, I'm going to just move you down onto my demonstration table here. Okay, let's make sure I've got lots of, there we go, fantastic. Right, so I'm opening this up, all right? Might just lift this up slightly so we can see it a little bit better. There we go, perfect. Now, in this game, we have a blue piece of fabric. Now, you might have something like this at home, or you could draw something like this on a piece of paper or use cardboard or a tray, anything at all to act as your sea. And you'll see in this particular game, we have got some sea creatures. I won't be able to name particular types of fish here. I'm not sure. Maybe that's a bass. I'm not sure. But I know this is a crab. And we have, let's put one more down here. So you have the sea, you have your sea creatures, okay, and you have your fishing rod, okay, your fishing rod. So what we are going to do is there's a magnet inside the end of the fishing rod here, okay, and thinking about it, if you wanted to, you could, if you're making this, I mean, you might not have a bit of wood to hand, but why not use a pencil, tie some string to some pencil, and if you do have a magnet, then tie that magnet to the end and you've got your very own fishing rod. Okay, so get really creative and use the things around you that you have. Be resourceful. Now then, I'm sure you can guess what's going to happen. I'm going to hover my fishing rod over the top of these, and we know that as soon as the magnet gets close enough to the magnetic metal, it will pull the magnetic metal into its magnetic field, and it will attract, there it goes, and I can lift up, and I've caught Mr. Crab over here, so I'm going to pop him down there. And then this game works again where you have to be really accurate and lift them up. Now you can do this in quite a slow fashion. This kind of game would work like this, pulling them up. Wanting to use that scientific word, attract. It's attracting the metal on the fish into its magnetic field. And there we go. Now you can make this even more fun. I can actually make this game even better, rather than sort of just having a go and doing it quite slowly. You could set yourself a timer and see how quickly you can pick up in a minute. Oh, that's tricky. Let's go. Fantastic. Or if you make 2 fishing rods, you could play against somebody else and you could see how many you each can get. Possibilities are endless, but what I would say is, as you're making these games, really consider how that magnet is working to attract the metal of the paperclip or of the metal on here right up into its magnetic field. Okay, so when you're writing later, I'd like to see you using the words attract and magnetic field. Okay, right. So I'm just going to show you also, you obviously might not have some of these pieces, so I'm going to pop those away. And if you actually want to physically make this game yourself, there's absolutely no reason why you couldn't take a piece of paper. Now I'm going to make life simpler for myself. I'm going to draw myself a starfish here, okay? So I am going to start here. And I've got a very, very simple starfish. Now what you can do, okay, is you can cut this out. I'm just going to very quickly cut it out like this. You at home can take a lot more time. You could add colour, okay, to present this. You can cut this starfish out like this and attach a paper clip to it. Okay, so that's my magnetic metal there. And then if I place this on my sea, again, exactly the same idea. Should work quite nicely. We've got our magnet. If I hover it over, look at that, I can collect my starfish. How exciting. So as long as you've got paper clips and some kind of magnet maybe raid your fridge if you've got something on there, then you can actually create your very own version of the fishing game. Brilliant. So I'm hoping you're getting some fantastic ideas for the game that you'd like to create. I really look forward to seeing them when they're done. Let's just go back to the board and share that last idea, which is a bit more tricky. So it would be a good challenge for some of you who do want to challenge in the design of the game. It says over here in our last example, why not make a magnetic maze? Draw a maze on a piece of card, hold a magnet under the card and try to guide a paperclip around the maze. Can you find your way to the center or make your way out? Okay. Now mazes are quite tricky to draw, so I'll put a maze at the bottom underneath the video, so at the bottom of this page, so you've got a template if you'd like one. I had a go earlier. I'm just going to show you this. Okay, I actually copied the one that was on the slide and then added a few of my own ideas. And it's exactly the same idea. Oh, we could have a starfish going through the maze. Just grab my magnet over here. There we go. Here's my start point. And I can work my way, a bit tricky with paper because it's a bit thin. I can work my way through the maze, down and out all the way to the finish. Okay, so another idea of a maze there that you could draw out. Could be exciting. Let's have a little look then at our final slides and look at how we can then write up our explanation of how it works. Okay, I'm so excited for this, if you can't tell already. So what you need to do now, this is step 2. Now we've had all of those ideas, now we understand that magnets can pull, can attract objects into its magnetic field, even through some materials. We now need to design our magnetic games. So you're going to use this sheet, which again is below this video, which you can print out if you have a printer, and if not, you can just look at the screen and use it as a structure on your piece of paper, so you can write out the different parts and draw out the box and draw your design inside it. You can even draw out the little pictures and the key vocabulary here as well. Okay, there's no reason why you can't still be as successful even if you don't have some of these other things like printers and things like that. So now use your magnetic game activity sheet to design your game and explain how it uses magnetic force to attract materials. So the first thing that you need to do is you need to make sure that you draw it out really clearly how it would work, and you include all of the equipment in there as well. Give it a title, okay, and then we need to consider this bit here, just a sentence or two to explain how it works using our magnets. So what I'd like you to do now is pause the video, have a think through some ideas. You might want to go back and re-watch part of this video to remind yourselves of them, and then get designing your game. And when you've finished that, you can unpause, you can play again, and we'll move on and have a look at step 3, where we can write out a STEM sentence to explain how the game works using that scientific vocabulary. So pause now, get designing scientists, and then we'll come back together for step 3. Off you go. Okay, welcome back. Hopefully you're really excited and really proud of the idea that you've come up with, and you've drawn it out really neatly, thinking about that high quality work that we want to do, take pride in our work. And let's just have a little look at step number 3 then. So step 3, I can use scientific vocabulary to explain how the game works. Now, sometimes we can be a little bit flummoxed, that's a good word, flummoxed, a bit thrown, a little bit unsure when we see the word scientific vocabulary, because we suddenly think we've got to get really scientific, and it's going to be really difficult using all these big words that we don't know. But actually, we do know these words, don't we? And we can understand them. Let's take a look at the words that we've got down the bottom here, our scientific vocabulary that we're going to use in our explanation sentences. It says, use these words to help you explain your ideas. So we have magnet, we have attract, iron, steel, paperclip, force, pull. Okay, you also might like to use this idea of magnetic field, and I've included that in here. So your task is to use these STEM sentences to help you explain how your game works. Explain as clearly as you can. Now look, there's 3 STEM sentences here, so there's not lots of writing, but we need to make sure the writing that we do is high quality and uses that scientific vocabulary. So here we are. My game works by, and then you explain how it works. The magnet attracts to the, whatever it is, and pulls it into its magnetic field. When the magnet moves, so does the whatever it is. Okay, so let's do one final coming back together. It's all well and good having STEM sentences which can help you, but there's nothing better than actually modelling writing together. So let me get my whiteboard rubber, get rid of my racetrack here. And I'm going to be explaining my racetrack game. Okay, so I'm going to start with my game works by, because that's my first STEM sentence. My game works by. Okay, I'm going to think it, I'm going to say it, I'm going to write it just like I would do in my English lesson. So how does my game work? Well, actually, when it was the racetrack game, wasn't it? It works by moving a paperclip or a racing car around a racetrack using a magnet to attract it, okay, through the material. So my game works by moving a paperclip race car around a track. Full stop. My game works by moving a paperclip race car around a track. Aha. And I'm going to extend my sentence here because I need to include something really important, my magnet. My game works by moving a paperclip race car around a track using a magnet. Okay. So I am going to then look at my second STEM sentence. Okay. So when the magnet moves, okay, when the magnet moves, it attracts, I'm going to get my key science when it attracts the paperclip into its magnetic field and the paperclip moves as well. When the magnet moves, oh look, that's not a fronted adverbial we've got in here. When the magnet moves, I'm going to put, I'm going to change my mind. So too does, in fact, no, that's going to start sounding complicated. I'm going to edit that now. When the magnet moves, it pulls the paperclip into its magnetic, misspelt that one. Got to have high quality. Let's just correct that. Into its magnetic field. And so the paperclip race car moves around the racetrack. I'm adding that extra here, through the paper. Okay, fantastic. I'm just going to just double check I've used all my scientific vocabulary. I think I might need to improve that. So I've got magnet, using a magnet. When the magnet moves, it pulls. So I've got this idea of pulling. It pulls the paperclip into its magnetic field. And so the paperclip moves around the racetrack through the paper. Final sentence. This is because the paperclip is attracted to the magnet. And then I'm using attracted as well. This is because the paperclip, oh, just going to move that back a little bit so I've got space to write. Oh, I've even thought of something else that I can add in. The paperclip is magnetic. That's another word, isn't it? It is magnetic. And, oh, check out this conjunction. And therefore, attracts to the magnet. Full stop. Wow, look at all that. Fantastic. I'm really glad I added that last bit on so I can get all my scientific vocabulary in there. And so the paperclip race car moves around the racetrack through the paper. This is because the paperclip is magnetic. There's another bit of vocabulary. And therefore, cracking conjunction, attracts to the magnet. There we go. Right, I'm really happy with that explanation there. Okay, you can magpie my ideas here as well for your game and adapt it if your game works slightly differently. Let's finish off then, shall we? Go back to our slides. So here are some sentence stems that you might like to use to help you. You can obviously use my modelled writing as well. And remember, it's that scientific vocabulary, okay? We could have explained this in a way where we didn't use those words, but it's really important that we really cement our scientific knowledge in our minds, in our brains, by using it now in our writing. So pause the video, have a think, use the live writing model and your sentence stems and come up with a way of explaining in, say, 3 or 4 sentences how your game works. Okay, pause now. Brilliant. Okay, well done. I look forward to seeing these games. I really hope you've stuck with us and you've done all 3 steps and had a go at them. Let's just see what our final part, of course, it's our quiz to see how much you have remembered from this lesson. Okay, so our learning objective was to explain how magnets attract magnetic materials. Okay, and we have 5 questions just to test your knowledge and to see how much you can remember. So let's go. Number 1, pencils at the ready. Draw a bar magnet. So remember what that one looks like. Draw a bar magnet and label the poles. Off you go. I'll give you a little moment here just to draw that out carefully. So think about what a bar magnet would look like and label the 2 poles. I know you can do it. We've looked at these a lot, haven't we? Okay, number 2, draw a magnetic field around it. Oh, that's going back to our lessons last week. So that invisible magnetic field around the magnet. So have a little think about how that would look. Okay, brilliant. And if you need to pause at any point to draw this out really carefully, of course, you can pause me and then come back. Okay, question 3 then. What is the name of the object with a magnetic needle in it that always points north-south? So thinking of an object, very useful object, especially for explorers and travelers and people on a journey. Number 4, with magnets, what is the scientific term for pushing away? So when the magnets don't stick together, they push away. What is that called? And finally, with magnets, what is the scientific term for pulling in? We've actually used it here in our modelled writing. So what is the scientific term for pulling in? Okay, have a think, write those down, and then let's go through the answers. I don't have an answer slide, so I'm just going to read out the answers now to you so that you can mark with a different pen. And don't worry if you've got any of this wrong or you couldn't remember. Okay, now is the time in a different colour to not rub out any wrong answers, but just to add the correct ones in so we can learn from them. Okay, so your bar magnet, okay, should look something like this, and I'm going to very quickly draw it on my piece of paper here. It doesn't matter if yours is a different way round, but it should look like this. Hold it up nice and clear. So you've got north on one side, South Pole on the other side. So the North Pole and the South Pole, they're opposites there. And even better, give yourself an extra tick if you use the colours, because that's a fabulous idea to help you remember those two different poles. Brilliant, well done. Now, the next question was to draw a magnetic field around it. Okay, so I'm just going to quickly add my magnetic field in so you can see here. And remember, the stronger the magnet, the bigger, the greater the magnetic field. Okay, so this magnet, for example, my little one here, has a smaller magnetic field than my bigger, stronger magnet over here. So this can pick up things from further away, or it could pick up perhaps heavier magnetic metals than this one. Okay, so let's take a look. It should look something like this, where you can see they sort of go round in arcs all the way around from one pole to the other one. So that's what your magnetic fields look like. Well done if you've got that. Number 3, what is the name of the object with a magnetic needle? Of course, it's a compass. We spelt that C-O-M-P-A-S-S, compass. Number 4, with magnets, what is the scientific term for pushing away? It is repel, R-E-P-E-L. You could have had repel, repelling, or repelled. All of those are fine. And of course, number 5, with magnets, what is the scientific term for pulling in? That is attract, A-T-T-R-A-C-T, attract. You could have had attracting or attracted, as long as you've got something that has attract. In fact, look, it's up here in our learning objective, attract. Brilliant. Mark, give yourself a score out of 5, see how you did, and then finish off, if you need to, your science work and send it in to our email addresses. Take a video of you playing the game if you've got it and send those in as well. And we'll perhaps spend some time sharing those on the Zoom tomorrow. Fantastic, good effort, well done everybody. See you again for some more science next week.